Hey everyone, how are you? In this video, we are going to solve the Leetcode problem of the day, and the problem is reschedule meetings for maximum free time part 1. Now the problem category is of medium level, but I would say this problem involves few of the easy concepts. You just need to combine those easy concepts and this problem can be solved. The input given in the problem is an event time and that's an integer. There is another input k, integer, and two more inputs. They are start time and end time, and they both are basically a sorted integer array of size n. So basically the start time and end time are having the same size. They are having n elements and they are sorted. The output which you need to give in the problem is the maximum amount of free time possible after rearranging k number of meetings. So basically I will tell you what this input is all about. So this event time is telling me that I am having a schedule, a complete schedule from 0 seconds, or you can say from 0 to whatever the event time is given. Let us say the event time is 10. It means there are meetings from 0 to 10. So event time is telling me what's the last data when the event or when the meetings are ending, and the meetings are going to start from 0. This is fixed. Now you can consider this 0 as seconds, hours, days, anything. It doesn't matter for this particular problem. The only thing matter is the event is starting from 0 and ending at event time, whatever event time is given. K is an integer which is given, and this k means that we can rearrange around k number of meetings. So this k is basically required for the output. We need to rearrange maximum k number of meetings to maximize the amount of free time possible. Now I will tell you what is this free time. For now, this k is being used here, right? That's the number of arrangements, rearrangements, maximum number of rearrangement you can do. The start time and end time is telling me about different number of meetings which are scheduled between the event times. So the event time is from 0 to whatever event time is given. Between this particular time, there are n number of meetings which are scheduled, and the meeting data, that is the meeting start time, the meeting end time, you can get it from the start time and end time array. Now let me try to explain you the rules which is very important to understand. The first one is something which I have already told you. The event occurs from 0 seconds to event time, or from 0 to the event time, and we are given n number of meetings. They are basically given in the start time and end time array. Okay, we are given n number of meetings and they are non-overlapping. Okay, they are not overlapping with each other, and for any ith meeting we can find the start time and end time of that meeting using start time of I to end time of I. Basically the ith element in start time and ith element in end time is going to tell me what is the schedule of ith meeting. And rescheduling means it is very important because we can reschedule up to k number of meetings to find the longest free time or the highest free time or the maximum free time. We need to change the start time of any meeting. We can change the start time of any meeting. We can change it for maximum k number of meetings, and we need to change the start time in such a way that for that meeting for which we are changing the start time, the meeting order should not change and the meeting duration cannot change, right? I mean, that's enough of the theoretical part. Let me jump on to the example to explain you how this question is going to look like, how we can reach to the output from the given input. So let us say this is one of the example in which the event time is 10, the value of k is 1, start time and end time are 0, 2, 9, 1, 4, 10. Event time 10 means I have events from 0 to 10. All right, this is my event timing. Between this particular time, between 0 to 10 only, all my meetings are going to be held. Okay, k is equal to 1 means out of all the meetings which are given, I can reschedule one meeting, and my target is to maximize the free gaps. Okay, so for now let us forget about this. Let us not consider this. Let us just see that what are the timings of our meetings. The timing is 0 to 1. It means that I have a meeting starting from 0 going till 1. All right, then I have a meeting from 2 to 4. It means I have another meeting which is starting at 2 and going till 4, right? This is one of another meeting we have, and I have another meeting which is starting from 9 and going till 10. Now one of the things you will have to notice that the meetings are in sorted order, right? That's given in the input. 0 to 1 is this one, 2 to 4 is this one, and 9 to 10 is this one, and they are not overlapping. None of the meetings are overlapping with each other. Overlapping means if I could have a meeting from 0 to 3 and 2 to 4 or 2 to 6, so this part is overlapping, right? Both the meetings are being held between 2 to 3, right? So this is overlapping, so we cannot do this, and the input will not have any such kind of scenario. So how will you find the output right now? If you forget about the value of k, the output we need to find is the maximum amount of free time possible, right? After rearranging k number of meetings, forget about rearranging, forget about k. I just need to find out the maximum amount of free time. So what is the free time? If you will notice here, My total timing is from 0 to 10. I have a meeting from 0 to 1. This is not free. From 1 to 2 it is free, right? I am free. I don't have any meeting, right? So this 1 is free. From this total gap is 1, right? 2 minus 1. This is, if you are saying that this is hours, so from 0 to 1 hour I am not free. From 1 to 2 I am free, right? So this 1 hour I am free. From 2 to 4 I am not free. But from 4 to 9, this 1, 2, 3, 4, 5, 5 hours, 9 minus 4, 5 hours I am free, right? So I have two number of free timings. I have 1 hour free, 5 hour free, right? The maximum free timing is 5, right? That's what we need to return. But now there's a twist. We can rearrange k number of meetings. If we can rearrange k number of meetings in such a way that we can maximize the free time, right? Then that is the output we need to give. We basically need to rearrange the meeting, rearrange one number of meeting. We have 3 meetings, right? 1, 2, 3. We can rearrange one of them, and our target is to maximize the free time. So for this particular problem, forget about the programming, forget about the coding part. How can you just rearrange it? How can you rearrange it in such a way that you are maximizing the time? Now there is a rule for rearranging. You can change the start timing, but the meeting order and duration cannot change. It means that if you want to rearrange this meeting, you can change the start time of this meeting. You can say, okay, this is starting at 0 to 1, it is going till 1, it is of 1 hour, right? I can say it can start at 1 and go till 2. Instead of 0 to 1, maybe I can say it can start at 1, go to 2. This is fine. That's because if I just move this meeting here, right, then as of now it is completely fine. It is starting at 1, going to till 2. It is not overlapping, right? It is not overlapping with any other meeting, and the meeting orders are not changing. This is meeting number 1, this is 2, this is 3. As of now, even after rescheduling, the meeting order is fine. But what if I would have done it like this? Instead of from, I would say, from 0 to 1, I would have said, okay, let's move it to 6 to 7. So as of now, one thing is fine, it is not overlapping, okay, but the orders of the meeting are changed. This was the first meeting, now this is the second meeting, right? This is the first, now this is the second, this is the third meeting. So this is not valid. I cannot do it, okay? So what I will have to do is I have to just reschedule the meeting in such a way that they are not overlapping. That's the first rule. And the orders are not changing, and the duration should not change as well, okay? If a meeting is from 2 to 4, just to increase the free time, I cannot say I am rescheduling it from 2 to 4 to 2 to 3, okay? This is not valid. This can increase the free amount of time from 5 to 6 hours, but this is not valid. So what can you think? How can you increase the gap? Now just by looking at the picture, I can say, okay, if I can just remove this meeting from this place and move it here, that is, instead of the meeting being from 2 to 4, if it is from 1 to 3, then the gap, the free time is now 1, 2, 3, 4, 5, 6, 6 hours. Earlier we had two gaps, two free timing. We had 1 hour free from 1 to 2 when the meeting was at 2 to 4, and then from 4 to 9 we had this 5 hours, we had this 1 hour. Now we have rescheduled this meeting to 1 to 3, and now we have just one free timing, but that free time is longer, maximum, right? We are having a total of 6 hours free. That is the output for this particular input. We will have a 6 hours free timing after rescheduling one number of meeting. Now up to this point, I think we are clear with the question, we are clear with the things we need to do. But now how will you do it? Like, how will you solve this? Just by looking at the particular graph, you can solve it. But programmatically, how can you think? Or forget about programming. Mathematically or logically, how can you think? Why are you moving this here? You can see and move it. Why are you moving this meeting to this place? That is because I have a gap, right? This gap is of, I would say, 1 hour, right? We have a 1 hour gap, and we have a 5 hour gap, right? We are having two gaps, okay? These gaps are not continuous, right? If they would have been continuous, then this would have been a 6 hours gap instead of 5, right? So if we can just make them continuous, we can increase the gap, right? If we can increase the gap, it means we can maximize the timing. So what can you think? How can you think about this? See, the thing is, if we have two gaps, right now we are having two gaps. If we are moving this particular meeting, and if we are moving it in a smart way, in a good way, we are moving it from 2 to 4 to 1 to 3, then what we are actually doing is we are saying, okay, we have a meeting from 0 to 1, then 1 to 3. Now we just have one number of gap, right? So we are saying that there are two gaps. After merging one meeting, we are having one number of gap, right? So if you are merging one meeting, the number of gaps are going to reduce, right? If we are rearranging one meeting, the number of gaps are going to be reduced by 1. We had two gaps, now we are going to have just one gap, right? As of now, it is clear, right? Now let us say there is one more meeting which is from 6 to 7. Okay, if we have one more meeting, now you will notice that the gaps are different. We have a gap of 1 hour from 1 to 2. We have a gap of 2 hours from 4 to 6, right? We have a 2 hours gap. and from 7 to 9 we have a 2 hours gap. Okay, now if I will ask you how can you reschedule the meeting one times to maximize the gap or maximize the free timing, right? So the moment if you are able to think about how can you find the answer logically, that moment you will hit the actual programming solution. Now if I move this particular meeting from 2 to 4 to 1 to 3, then what will happen? One gap, this particular gap is being filled. I am removing this gap, but this gap is not going anywhere. This gap is being added to one of the gap we are having. This is a 2 hour gap, this is a 1 hour gap. When we are rescheduling this meeting from 2 to 4 to 1 to 3, now what we'll have is we will have a gap from 3 to 6, a total of 3 hours of gap, right? So what is happening when we are rescheduling any one meeting? When we are rescheduling one meeting, then we are actually merging two continuous gaps. That's what we are doing, right? If we are rescheduling this, we are merging this and this gap. The gap was 1 and 2 separate. Now we have a continuous 3 hours of gap. That can be one of the answer, right? I mean, that we can do, right? But that's not the best answer for this case. And how can you find the best answer? Okay, let's try another rescheduling. If we have one reschedule or rearranging allowed, let us try for this one. If we can move this 6 7 instead of 6 7, can we make it at 5 6? That's one of the option we have, right? Instead of the meeting being from 6 to 7, if this meeting is from 5 to 6, let us say this is from 5 to 6, then you will see that the gaps which we are having is 1 hour here and a 1 hour gap here and a 3 hours of gap here, right? As of now our gaps was 1 2 and 2. Now the gap is 1 1 and 3, and now you will say that even we are rescheduling, the number of gaps are not decreasing. We were having 3 gaps, still we have 3 number of gaps, and that is because that's not the best way, that's not the best strategy. Why are you leaving any gap? You should not leave this gap, and that's because instead of moving it from 6 to 7, if we can reschedule this particular meeting to, let's say, 4 to 5, okay, if we can reschedule it from 4 to 5, now you will notice that the number of gaps which we have as of now is 1 hour of gap here and a 4 hours of gap at this particular point. The number of gaps has been decreased. It was 1 2 2 3 number of gaps. Now we have 1 and 4, just 2 number of gaps. But since 2 of the gaps are combined, now the maximum free time of gap is 4 hours. That is the answer for this particular scenario, right? Now from here I can see a pattern. There is a pattern which is being built. If I am rescheduling a meeting one time, right? If I am rescheduling a meeting one number of times, then what's happening is these are my original gaps which I was having, right? 1 2 and 2. I rescheduled a meeting one time, and with the best strategy, if I'm using the best strategy, the number of gaps is going to decrease, right? And 2 of the gaps are combined to form a bigger gap. If I'm rescheduling one meeting, 2 gaps are being combined, right? If I could reschedule 2 number of meetings, then I can say that if I have 3 gaps originally, that will be reduced to 1 gap, and 3 of the gaps are going to be combined to form a 1 gap, and that is going to be the max. Let me try to show you that. So originally what I had is this particular 4 to 5 meeting was at 6 to 7, right? Now this is my original data. I have 1 2 and 2, total 3 number of gaps. I have one option, maybe let's say I have just one option. Instead of that, let us say we have 2 number of options or 2 number of meetings which we can rearrange, right? Now the best strategy, I will tell you the best strategy. You can try a lot, you can try to reschedule different meetings, but the best strategy is try to combine 2 meetings, try to make 2 meetings continuous so that the gap is being gone, so that the gap is decreased. So let me utilize the first rearrangement. I can say instead of this particular meeting, the 2 to 4, let's make it as 1 to 3. That's the first thing I will do. Okay, now I will have just 2 number of gaps. After one rearrangement, the number of gaps has been decreased by 1, right? So now I just have 2 number of gaps. So let me get rid of this. Now I have 1 gap here which is of 3 hours. I have 1 gap here which is of 2 hours. My original gaps were 1 2 and 2, right? These are my original gaps, and now my new gaps after rescheduling one time is 3 and 2, just 2 number of gaps, but my 2 gaps are now combined to form a bigger gap. Now I have one more option. So what I can do is, instead of this meeting being at 6 to 7, I will say, okay, let me reschedule you from 3 to 4. Now I just have one gap, a continuous gap of 5 hours from 4 to 9 because my two gaps 3 to 2 are now combined to form a bigger gap. Bigger gap means bigger free time. So I have a 5 hours of free time. This 3 and 2 are now combined. So 5 hours of free time, that is going to be the output. So from here, what I will tell you is my original gaps were 1, 2, 2. When the value of k was equal to 1, that is we were allowed one rescheduling, the output was 4. When the value of k was equal to 2, the output was 5. Basically what is happening, when these are my original gaps in my meetings, okay, these are my original gaps. Out of these gaps, if you will notice, when we are rescheduling for one time, we are basically, combining two gaps together. If we are rescheduling it for 2 times, we are combining 3 continuous gaps together, right? So that's basically saying that if for whatever k is which is given, when I am rearranging k number of meetings, I am basically merging total k plus 1 gaps together. Now my strategy of this merge will be to merge those gaps together, to merge those k gaps together into k plus 1 gaps, which can produce the highest free time. For example, for this particular case, I have 3 number of gaps, a gap of 1 hour, 2 hour and 2 hour. I am just allowed one rearrangement. So what will happen? I am actually merging k plus 1, that is 1 plus 1, 2 number of gaps together, 2 continuous gaps together. So I can say 1 plus 2 is 3. I could merge these two gaps, or I could say 2 plus 2 is 4. I could merge these two gaps, right? Obviously this is going to be the highest, right? 2 plus 2 is going to be 4. That is going to be the output. So our strategy will be to find the number of gaps we are having, and after finding the number of gaps, we are going to find a window of k plus 1 size, and that window of k plus 1 size for which the sum of that window is highest in all our gaps, right? The question is now about finding the best k plus 1 sized window sum in our gaps. So I think that's the whole strategy we can follow in this particular problem. And I think now you have the idea, now you have the intuition to think about the solution. Instead of rescheduling the meeting, try to work on the gaps. If you are able to work on these gaps, try, and you can get the gaps, and now you have the idea that if we have k number of rearrangement, I am actually merging k plus 1 gaps together. Try to merge the k plus 1 gaps in such a way that they can produce the highest value. So basically try to find the k plus 1 window, that is a window of size 2 for this particular case, for which the sum is highest. 1 plus 2 is 3, 2 plus 2 is 4. This particular sum is highest. That is going to be the output. Now let me take you back to the code editor and let me try to show you the solution for this particular problem. So first of all, we are creating an array, and that array is called as gaps. We are storing the gaps in this array. All right. After storing the gaps, what we can do is we can say the first gap will be from the first start time. Okay, let me tell you this as well. Okay, how can you find the gaps? And this is a very easy process. Okay, now these are your meetings, right? These are your scheduled meetings. Your whole timing is from 0 to 10. 10 is your event time. The first meeting is from 0 to 1. So a gap can be before the first meeting. There can be a gap before the first meeting. For example, if this meeting was not there, then the first meeting will be from 2 to 4, right? From 2 to 4. So there is a gap here. So the first gap is going to be the start time, the first start time minus 0. 0 is our starting time of the event, and that is why the first start time minus 0 is going to be our first gap, right? Our last gap is going to be the event time minus the last meeting ending time. That's because let us say this is not the meeting which is there. Okay, this is our last meeting from 6 to 7, right? At 7 our meeting is ending, so this is the free time, this is the gap. So basically this is my event time, and this is my last meeting ending time. So this is going to be the last gap. So we know how to find the first gap, we know how to find the last gap. What about the mid gaps? What about the gaps which are between the meetings? Basically the different gaps is going to be the starting time of the new meeting minus the ending time of the old meeting, the previous meeting. If you will see here, we have a meeting from 0 to 1, right? The next meeting is from 2 to 4, right? So this is 0, this is 1, this is 2, this is 4. So we have a gap here, right? Basically the starting of the new meeting minus the end of the previous meeting. I mean, that should clear the logic, right? So now let's go back to the editor again. The first gap is going to be the start time of our first meeting minus 0. Then this is our last gap, the event time minus the last meeting ending time. Between this we have a logic that we are running a loop from 1 to the length of the start time, and our gaps are going to be the starting time of the new meeting at the ith index minus the ending time of the previous meeting at the I minus 1 index. Then what we are going to do is we are going to find the sum, the maximum sum possible of a particular k plus 1 window. So as of now we are saying that okay, the first k plus 1 element is going to be my window, and that is going to be my result, the first k plus 1 window in my gaps. And I'm assuming that that's maximum, but we are going to update our maximum value by running a simple algorithm. we are going to say from I in the range of k plus 1 to the length of gaps, we are going to create a new window. So basically what we want to do is, let me again go back to the pad and let me try to explain you. If our gaps are 1, 2 and 2 and the value of k is 1, so in this case we need to find the window of size 2, right? This is my original window and the sum is 3. I am saying this is my first original window. Then I will move my window at this particular place. So what will happen? I will get a new value which is going to be added into 3, and I will remove the previous value which is going to be removed from 3. That is going to be the sum of my new window. 3 plus 2 minus 1, that is going to be 4, the sum of my new window. So that is the logic to find the sum of every k plus 1 window instead of just looping in every k plus 1 window. So I can say for I in the range of k plus 1 to the length of gaps, the next window is going to be my current window minus gaps of I minus k plus 1, that is the previous element which we are leaving behind from our window, and the new element which we are adding in the window is gaps of I. Then our result is going to be the max value of existing result and the new window. After we are out of the loop, we can just directly return the value of result, and that is going to pass all the test cases for this particular input. And this particular solution, guys, is actually very efficient. You can see the runtime is good, the memory used is pretty good. So that's the complete solution for this particular problem, and this is actually very efficient. Okay, we have solved this particular problem, and that's it for this video, guys. If this video helps you to understand the problem and the solution approach, and especially if you are able to understand the intuition behind this particular solution, then please hit that like button. And if you have not subscribed to my channel as of now, then make sure that you do subscribe to the channel. We are very close to 1000 subscribers, so I want to achieve that milestone very soon. So make sure that you put out your support, and if you have any questions, any feedbacks, then you can put it in the comment box. I'll try to provide you the solution, provide you the answer, or based on your feedback I can work on it. I will see you in the next video. I want to see you in the next video as well. So make sure that you do subscribe, and thank you for watching this video, guys.